Today we're going to be talking about polar coordinates. We've been using the Cartesian or rectangular coordinate system to graph. Another useful coordinate system is the polar coordinate system, which uses distance and direction to specify the location of a point on the plane. The system is based on a point called the pole or origin and a ray drawn in the direction of the x-axis called the polar axis. Let's take a look down below. R represents the distance from point O to point P. So R is this distance here, and theta is the angle between the polar axis and the line segment OP. So here theta represents this angle here. So previously, the way that we represented a point on the xy plane is we used x comma y, where x represented our horizontal distance and then y represented our vertical distance to get from the origin to our point P. But now we are exploring this new system where you can kind of think there's like a little person at the origin, and instead of walking horizontally and then vertically to get to our final destination, instead, what the little person is doing is they are rotating some angle theta, and then once they've rotated in the correct direction, then they're walking to that point and ending up there. So again, we have kind of two ways of getting to our final destination, that ordered pair. We can walk x units horizontally and then y units vertically, or we can rotate an angle of theta and then walk r units to get to our final destination like that. So hopefully that little picture with the person walking on the plane is helpful in thinking about this new coordinate system. Theta is positive if measures in a counterclockwise direction from the polar axis. So this is the polar axis here, and if we rotate in a counterclockwise direction, then theta is positive. And it's negative if measured in a clockwise direction, which we should be used to because that's how we've been measuring angles previous to this. If r is negative, then P is the point that is the absolute value of r units from the pole in the direction opposite to that given by theta. Let's go ahead and look at an example. Example 1 says, plot the given points. Part A wants us to plot the ordered pair 5, 2 pi over 3. Now remember, this value here represents r, and this value here represents theta. So if we start at the pole, what we want to do is we want to rotate 2 pi over 3, and this plane is nice because it shows us the angles here. So we've located 2 pi over 3. So if we are on our polar axis and we rotate that much, that gets us to 2 pi over 3. And then if you thought about a little person standing right here, they would walk towards 2 pi over 3 where our line segment is 5 units. So I'm going to go ahead and count. Each of these circles represents 1 unit. So 1, 2, 3, 4, and then I'm going to change colors, and this will be my ordered pair here. So that point there is 5, 2 pi over 3. So for part B, we want to graph the ordered pair 2, negative pi over 4. And remember that this is r and this is theta. So we want to start with our polar axis here, and our little person, they're looking off into the direction that way. Oh no, I chopped off his arm, or their arm. Okay, so if we want to rotate negative pi over 4 units, then we want to go in the clockwise direction. And so here's the vertical line, and I know that negative pi over 4 falls between the vertical and the horizontal. It's in the middle. So that would be this line here. And then I want to go out 2 units. So I have this little 1 unit, because that's the first circle here. And then the second circle represents 2 units. So my point is going to be right there. And that represents 2 comma negative pi over 4. And I'm realizing, I'm drawing a lot. Really, we just want the final ordered pair. So I'm going to maybe erase all this other stuff. So that's how we want to plot the ordered pair 2 comma negative pi over 4 on the polar coordinate system. Okay, so part C wants us to graph 4 comma 3 pi. So if I'm starting at the pole and I have my polar axis here, if I rotate here, that would be pi, and then 2 pi, and then 3 pi. So I'm going to go ahead and erase all of that. And basically we know that our ordered pair is going to fall somewhere along that line since our R value is positive. If it was negative, then it would fall somewhere on this line here, but R is positive. So we're going to go out 4 units. So let me switch colors. So here's 1, 2, 3, and then 4 is right there. And that is the ordered pair 4 comma 3 pi. All right, part D wants us to graph negative 3 comma pi over 6. So if I'm starting here, pi over 6 is this angle here, and notice our R value is negative 3. So if it was positive 3, normally we'd go 1, 2, and then our final point would be there, 3. But because it's negative, we need to go in the opposite direction. So here's pi over 6, and if I extend that line, I want to make sure I'm going on the right one. So pi over 6, and then 7 pi over 6 would be on the other side. And if I'm starting at the origin, I want to go out 1, 2, 3. So I'm going to go ahead and erase all of that. So this is 3 units out. And that point there is negative 3 comma pi over 6. So again, it's important to note if your R value is negative, you want to go in the opposite direction of your line segment.